Looks good. I think everybody is here. And let's start with our today's presentation or webinar. Nearly the same. Capturing the best image, even under demanding conditions. Subtitle strategies for industrial vision systems. First of all, I would introduce a common sense, but I think most people, especially in the age of AI, simply think this is not really important. But of course, it's one of the important thing for machine vision still since machine vision is available. And that means if you want to see something, we need good contrast at the end. And to get a good contrast, we need a good light, the right lens, maybe some filters, the fitting sensor, whatever it is. Finally, also some computer platform, depending on what we want to run it on. And of course, the software. Finally, without the software, nothing works at the end. And of course, our key product is software, the iVision software. So it's for us also important. But it's still valid to say, okay, the first 50% of machine vision system is lens, light, and the right sensor. And the other half is then the computer, the software, and the communication with the machine. So today we are focusing, of course, on the left side. And the left side means, oh, someone is still here. Let's see. Okay, the next one enters. The left side is the important side, and it defines if there is a success at the end. So what we have to do first is to define what do we have to do. How can we capture the image, or how should we capture the image to get the optimal image? And there, one of the major things is to have simply a choice of cameras. And in many cases, depending on, because after all, you have to process the images on any hardware and with any software, it's necessary to have a choice in the camera. Because if you need let's say, a very perfect color image, it doesn't help to have a gray camera or maybe a very not so good RGB camera. Maybe you need any fine nuance of color image. You need maybe a special color camera with 3 sensors and beam splitter to have the best resolution in color. And one of the major parts is then that you have at the end, of course, I just discussed about the light and the lens and the sensor. You need a software which allows you to select from the choice of cameras which are on the market, the one which fits best to your needs. At the end, not to your needs, to the needs of your product, which you want to inspect. And of course, iVision also has AI inside, and many people say, okay, light and lens, mainly I take any webcam and I can do the job. Of course, that's not true, finally. Even if everybody let you know, or look, AI can do it. Finally, if you maybe if you simply want to recognize a part, AI can do it. Like it can do it on your mobile phone, but in industrial use, you have mainly some other constraints. And therefore, you need then at the end the fitting camera for your needs. And optimally, you have a choice of camera manufacturers, which allows you to select from their cameras, from their choice of cameras, the right one to make your solution. And also, it seems that this is a general purpose playground. Of course, we have these standard interfaces like Vision, which allows you finally to connect all the cameras which fit to that standard and mostly independently of the manufacturer. But even this is not totally correct because uh, even if it's the standard, it's sometimes necessary to do some adjustments to use these cameras from the different manufacturers. On the other side, especially if you needed some specialized cameras like hyperspectral cameras or many of the 3D cameras which are on the market, they simply didn't support the Vision um, standard. Then you need to use the SDK, and therefore, if you select a software which doesn't have the option to select simply from or optimally all the camera manufacturers, then you have to use the next best sensor. And maybe the next best sensor, even if you have AI, it's maybe not working because you don't get that contrast on this next best camera. So one of the, beside the lens and light, it's always necessary to have the option to use also a sensor. As I use the word sensor, not camera, not because I think uh, um, I don't want to say camera because not always a camera is maybe mainly used in many cases for uh, sensor for light situations or for the visible light. In many other cases, like thermal, of course, it's a sensor, but in all 3D ways, many people say sensor because, of course, it's not a classical camera. So anyway, the important thing is that you can select from the choice of manufacturers the whatever camera fits to the needs. If you want to capture a sphere image, of course, it's good if you have a choice of different camera manufacturers. There are not so many um, manufacturers who have sphere cameras. Or if you need maybe more complex, a hyperspectral camera, then you are much more selected. You have only maybe 2 or 3 manufacturers. And of course, most of the hyperspectral cameras are not GigE Vision, because simply the standard, you can add these functionality to the standard, but it's not something which you simply can connect to any software. And or sometimes you need a high-speed image because a high-speed camera, and where GigE Vision, the current incarnation of GigE Vision, is too slow. Let's say for the majority of applications like standard machines, the 1 gigabit GigE Vision is enough. And of course, today you can get a 2.5 and 10 GigE cameras, and there are some new ones upcoming which are faster. But in many cases, if you have very high resolution and very fast cameras, Co-Express is right now, is for the moment the choice you have to use. And therefore, you need a camera manufacturer which has a camera. First of all, a camera with Co-Express, and you need a software which can do Co-Express to do this. Or maybe some outdated camera link. Camera link is for the moment in replacement with Co-Express. Co-Express is the newer version, has a lot of advantages, and finally it's the better solution if you build a new high-speed solution. The former standard was for very high-speed applications, Kamaling. But of course, Gig Vision and the next version beyond the 10 Gig E, it will be very close to QuarkXpress. So let's say in 95 to 98%, you could do it with Gig Vision as long as you have a camera manufacturer which supports it. Or beside of this, many cameras use anyway gigabit Ethernet and not the standard. Then there is an SDK. So the software has to implement the SDK that you can use these cameras. The sensor is really an important part if you capture the image, beside lens, light, and filters. And why lens and light, and why we still talk about lens and light in the age of AI? Because first of all, even a human cannot see in the darkness. If you switch off the light, you don't see it, and an AI also can't see in the darkness. If you have a camera with the visible spectrum, of course. Now comes the advantage of machine vision. Most of the sensors can see beyond the spectrum of the eye. So you have wavelengths where, but of course, if there are no wavelengths in the darkness, in the total darkness, then also the camera cannot see. The light and the camera has to fit, and if there are no photons or no rays, let's say it rays, because thermal is a kind of ray and not a photon. We can discuss it physically, but let's do it on this point. Then you need any kind of let's say light source or ray source to see something, even in darkness. And if you don't have these rays, you don't have this light illumination, even with AI, you cannot see anything. And finally, there are a lot beside of AI. AI is a growing factor in machine vision. Beside of AI, there are still applications which simply need contrast. Many people forget in the age of AI and the hype of AI that a lot of machine vision applications do measurement. Measurement means you do optically what you do with maybe a caliper or a measuring machine. You search for edges. In this case, not with a caliper manually with a caliper or a measuring machine. You do it with the edges of the parts, and therefore you have to illuminate it. And the edge of a part directly corresponds, the accuracy of the edge directly corresponds with the light, with the contrast. If you have a very good contrast at the edge, you can do a perfect measurement, and you can do it with repeatedly with a very high accuracy, as you can do it with a measuring machine or with the caliper. It's only a question of calculating the edge position. And the edge position, that's why I focus on the light in this case, on the light, lens, and contrast filter. The edge changes instead of the physical edge, the edge of an object in a camera changes based on the light, on the contrast. Let's say contrast, because it's not only light, it's the complete part of contrast belongs to the lens, to the filter, and to the light. In most cases, some of these are simply forgotten, and then finally you wonder that you have a measuring application and you get any numbers, but always different numbers and not the same one. And therefore, to measure in images is something which an AI can't do. AI can, of course, give you an idea about the size as a human has an idea of a size. So if you are used to work with any measuring device in the real world, you can take maybe a text marker and you can say, okay, I know this text marker here. Oops. And I know maybe this is 2.5 centimeters width. Uh, this this is what you can give as an as a neural network, and artificial intelligence can do the same because, of course, it cannot exactly define the edge of this part. Um, but if you have to measure, and in many vision applications, you have to measure exactly, or that's why vision is used. Also, you can measure parts with the speed of the production and with the accuracy you need finally. So that means it's only for this part of the application you need a perfect light and lens. If you have after the measurement part some additional things like finding scratches or finding dents or any other defects on the part, of course, it's not a question that you can use AI additionally. And finally, if you do this, the AI also gets the advantage of the good light because it works much better if the light situation is good than if it's not good. So the advantage of AI is it can also work if it's not so good. But if you want to have a reliable, really good result, light is always good. In any case, as light and lens for a human is good if he has to see something. The only restriction in the between or differentiation between the human and the camera and the sensor is that humans can see only in the visible area, and the cameras can see much beyond of everything. This is the main idea why we think about sensors and why we think about connectivity. Connectivity allows you simply to select the right sensor. Beside of what I told you about contrast and everything, the next step is if you know I can see some stuff only in a certain wavelength, you need a camera which works in that wavelength. Or if you have a high-speed uh, processing machine like filling of cans or stamping machines, which runs, let's say, between 25 uh, parts per second to 40 parts per second, then you need a camera which can meet the speed of this machine. You don't want to slow down the machine that you can inspect all the produced parts, and therefore, yeah, you have to search for the camera which fits your needs based on the wavelengths. Finally, then if you have the right camera, you need the interface. The camera has an interface, and you need a software which allows you to use this interface to simply make the solution. And uh, at the end, finally you have to select the right hardware to make your solution. After you have captured the image in any kind, you have to select what is my right hardware on which the software is running to fit the needs of the current machine. Either sometimes it's a question um, of the space you have, or maybe also of the price situation, which fits best. And therefore, it's also beside of the um, capture the image and get the best image, how to evaluate the best image, and therefore, what is the right hardware and the right operating system. It shouldn't be the reason why you use this camera to make the solution. If we go back here, if you have, for example, a smart embedded system like this one, of course, you don't have the option to select the CPU inside. You have to select also not the big choice of different sensors. In this case, you have to live with the light and the lens, which is built in of the system. And, and of course, of the computational power. If you have a standard system, it's difficult to run AI inside, of course. If you have maybe a specialized smart camera with an AI chip inside, like NVIDIA chip, then of course you can run these additional uh, tools on the image. Question is then, if we compare this to the interfaces, what is the right, what is the speed, and does it meet does my needs to the inspection meet with the speed of the camera and the image transfer, and finally the evaluation of the hardware. Of course, I just talked a little bit about control the light in the environment, and I just said light is not always light. That's what I just mentioned a little bit, but maybe to have a more a closer look to it. Of course, most of the sensors come without a lens. So first the question was, of course, how to get the right sensor in case camera. Of course, if you look to the many camera manufacturers and you use standard wavelengths, there's not a problem simply to find for the standard wavelengths, means in this case, standard wavelengths. What I mean in this case is the wavelengths which the human can see. If you simply focus on these wavelengths, there are some sensor manufacturers, and whatever camera manufacturer you have, for these wavelengths, you find on most known camera manufacturers the same sensors. Therefore, of course, you are free. Wait, there's someone new. I left him in. You have all these camera manufacturers which simply can deliver you for the standard wavelengths the cameras. That's not a question. The more important thing is if you have wavelengths or you have requirements where the standard wavelengths not working, then the number of camera manufacturers is reduces it. And if you have these reduced manufacturers, most of them doesn't support right now the standard interface like GigiVision, for example. And at this case, you need, of course, what I just mentioned, the software which fits the SDK or which supports the SDK of that manufacturer. But finally, on the other side, if you have not the standard wavelengths, of course, for the standard wavelengths, you get a large amount of lenses, and it's very easy. Even if it's not the standard wavelengths, the standard as a C-mount standard as attachment for the lenses. This is one of the standards which you find nearly for all manufacturers. But finally, what many people forget to make the best image is to have the right lens, of course. We have always, because we support all these camera manufacturers, and of course you can connect, depending on the interface you use, any of these cameras to the software. A lot of people buy a 20 megapixel camera and buy then a lens, and they tell us, look, especially for the measurement, we cannot measure the calculated accuracy. And then finally, we find out at that point, yes, they have a 20 megapixel camera, but they have a 5 megapixel corrected lens. That means the wavelengths which goes through the lens can only distinguish between 5 megapixel. That means it doesn't help you that you have 20 megapixel because of the lens. You only have at the end you can only distinguish between 5 megapixel. That's the maximal frequency which the lens transfers to the sensor. So even if you have a high resolution sensor and if you use wrong lens and maybe a perfect light, the accuracy you can reach or you want to reach, you can't reach it because simply it's a wrong lens. So it's really important always, beside of the contrast, to have also a focus to the right lens. If you buy an expensive camera with a high resolution, you have also to buy maybe not an expensive lens, but you have to buy a lens which fits to the camera resolution. This is something which most people don't think about or simply don't have in mind that lens doesn't mean lens. So of course you get always an image. You always get an image if you use a C-mount lens and you have a C-mount camera. You can use any lens and attach it and you get an image. But the resolution of the image depends on the resolution the lens can transfer. The frequency which the lens can transfer to the sensor. That's why lens is so important, and it's mostly sometimes forgotten or not really accumulated or thought about it. And of course, if you have the right lens and you have the right environment, maybe you are in a factory environment, then you have to think about light. Why light? Of course, and what light? Of course, light generates contrast. Contrast can be in any frequency, not only in the visible frequency. And in many cases, the visible frequency is not what we want. For example, if you are in a factory environment where workers have to work or are present, it's very disturbing for them if you use visible light, and if the machine produces it very fast and you have to use a flashlight, if you don't use the option of the camera to have a very short shutter frequency, or for whatever reason you have to use the flashlight, it really disturbs people if there is a flashlight which is running at 15 to 20 or up to 25 images per second, because the human eye can see it, and you disturb the concentration over the time if you use this kind of flashlight. In this case, of course, you have to think about maybe a light source which use UV light, because most of the standard cameras, which I mentioned before, which can see the full spectrum of the human eye, have also the option to see in the UV spectrum. And then you can use UV LED, any other light, but mostly today it's LED lights. And then with the combination of a fitting daylight cut filter, you eliminate for the camera all the daylight spectrum, and you only pass the UV light. First of all, the worker which is at the machine cannot see the UV light, and based on that, because he cannot see, he is not disturbed by the flashing UV light. And finally, for the camera, it generates anyway a very good contrast, because you eliminate the daylight which is necessary for the worker, but the camera, if these wavelengths are cut, the camera doesn't see it. So you don't get reflections because you have a ceiling light or whatever. You simply see the flashlight which you have installed. So the complete chain from light, lens, and filters. Filter, I just mentioned the daylight cut filter, but of course, if you're a photographer, you can use a lot of other filters to enhance the contrast. If you are in the visible light situation, of course, you can simply enhance these light. Can enhance the contrast of whatever you look to if you use the fitting filter for this application. So that was one of the main things you should think if you select the camera, the light, the lens, and filters. Of course, the question is, what is the right capturing technology? To have the good image means you need the right capturing technology for the different application. If you have maybe endless material like foils, metal, plastic, or woven stuff, or fabric, of course, you could use area scan cameras, but in most cases, a line scan camera is the right selection in this case, because you don't, due to the process, the material never stops. If you use the area camera, you have to connect the area images together. You have to stitch it together to make a continuous image on which you can operate. If you use the line scan camera, you can use with the process, with the production system, you can with the moving process for each millimeter or tenth of a millimeter, you can capture a line, and they will be connected together without additional CPU power, so that you have an endless material also in your main CPU on which you can operate then. For the line scan camera, exactly the same constraints belong as for the area scan cameras. With the line scan cameras, you have some advantages, of course. You don't have in the average, you don't have reflections, because the line scan camera has a very thin one, or let's say multiple lines, depending on the camera, either you have 1, 3, or sometimes 10 lines, but the average is 1 to 3 lines, where the likelihood is that you have reflections to these pixels due to the light is really vanishing nearly. So you have and of course you can place over the complete production area fitting light source, so that the complete area is optimal illuminated, and because you only illuminate this part, this small part, which is just under the camera, it's much easier to do the illumination for this part. If you have discrete objects, of course, in any production, the standard area scan cameras fit. So there's more a question, what do you want to see, or what do you have to see? Do you have to separate the parts to do the inspection? These are the different questions when you select the right camera. Do you need a color camera or a 3D camera? So, for example, if you do the fill level of these scans, then you could use the fill level or the pressurization of the cans. You simply can use 3D sensors, which generates you not only an intensity or a gray image, also a height image on which you can operate, so that you can maybe combine both operations on, you can operate either on the gray or color image and on the point cloud. So the question is more, what do you want to see and what you have to see to select what is the right solution for this application? Or if you have to count, for example, the X, of course, you could use, in this case, a 3D scanner, a sensor, and you could easily separate the X. This is maybe something which you have to make it very easily. You could use it before AI, a 3D sensor. And today, of course, you use an AI, you train the egg, and the AI can count the eggs, or it can uh, uh, separate the single eggs, and then you can count them. So in this case, if we compare it in the days before AI, either you use a complex 3D camera, which was not cheap, or you has to make a very special illumination that you can easily separate the eggs, especially if you have all the different eggs with different colors, and which was really a challenging thing to make it stable. And nowadays, of course, with an AI, even with a not so good illumination, the AI can count the eggs or can do the image segmentation or the image recognition, the egg recognition, let's say it this way. And you can make very easily an egg counter. So even with a not high-speed system, because the egg recognition could also run on very, let's say, low-powered CPUs. We saw it before. A Raspberry Pi with a color sensor would work perfectly to do this kind of stuff of task. In this, so that's why at what we said at the very beginning, what is the right sensor? What is the right choice to make the solution? And of course, the right choice changes over the time. As I just mentioned, maybe if, let's say 5 years ago, at that time, the AI was not powerful enough on these small systems, and the small systems were maybe also not powerful enough to run the neural networks which you need. You have to think about maybe a gray or color camera and a special light. Mostly you would have used a gray camera and a special light to get the gaps between the eggs, and then you can count it. It was possible, not that it's not possible, but it was not that easy as you can do it today with AI. At that time, you need a special, you have to thoroughly search for the camera, the resolution, the light, maybe some filters, the organization of the light around this egg box, and to make it stable in the process mode. And today, you simply attach a color camera on top of the belt. You get a trigger when the tray arrives, and you capture one image and you count it, and that's it. No problem. So the choice of the right sensor, light, and lens, or the right combination to make the solution between, let's say, 5 years ago and today changed totally. So what was true 5 years ago is today still true, but you can do it much easier. That's simply, if you have an idea how you made it 5 years ago, maybe you have to rethink it because you can make it cheaper and faster and more reliable. And this belongs to many other applications where you have to do things like here, if you have to find scratches on small parts. It was really complex, a complex situation, first of all, to capture the right image, and then to find how to find the scratches. Today, if you can generate a somewhat illumination, you find easily scratches. If you still want to measure it, you still need the good light with the good contrast to do the measurement. in many cases, it's not only detecting maybe scratches or some other, or simply anyway detect the right part. In many cases, you have two tasks. One task, it means measure me the whatever the dimensions of the part with the accuracy of whatever is needed, hundreds or whatever, and then find also some maybe defects or find some manufacturing artifacts like small metal parts which are attached to these to screws or whatever. So for the measurement, you still need the right lens light situation to have a stable measurement. Uh, but the evaluation of if there is for some foreign parts or foreign particles on the part, you can use now an AI to do it. Uh, where it was really difficult a few years ago, 5 years, 2 years ago. The AI development is so fast that even a truth ground you had 2 years ago has changed for today, except if you have to do things which AI can't do. Uh, not, for example, measuring perfectly. Um, the same is here for a system at the end of a ball feeder, for example. First of all, detect if it's the right part in the right orientation. It was always really difficult. What is the right setup? In this case, it's a setup of because the parts are on a belt, you can use a line scan camera, get a very high resolution. First of all, the AI can recognize what part in what orientation. That's what AI can do very easy. But more important is that the measurement, which you may also have to do some quality control, needs a perfect contrast. And a perfect contrast is, in this case, a through light situation where the light is on the back side and on the opposite side of the camera. To have a perfect contrast, with a perfect contrast, you have a perfect measurement. So the to get the perfect light means how to capture the image perfectly. And of course, depending on of your production unit, you need a camera which allows you to do the synchronization or with your production system. Also something which the sensor or maybe the light can do. So either if you use all the new cameras, they have a very good exposure time. So mostly you can use a trigger signal with a very short exposure time to get a stable image. For example, here for these scans, which are normally produced with 40 scans per second. Maybe sometimes it's necessary to, for some reason, because you need more contrast, you have to do some flash. So you need a light which allows you also to flash it synchronize in synchronization with the camera. So you have to select the right sensor camera, which allows you, first of all, to trigger the sensor, but also to initiate the flashlight that the flash comes while the sensor is active, to have the right sharp image in your system. Or another option is, for example, the 3D images. You have a built-in laser line in this case, and you have use a camera which fits to the synchronized laser line and the image capturing. That means at the end, to have a good image is to find the optimized exposure time, to synchronize also the light to the exposure time, and finally, what we always have to think about the bandwidths, which have to fit to the speed needs. And of course, once again, simply to mention it again, but because uh, small, fast forgotten, that you need always a lens which fits to your camera's bandwidth. In this case, the bandwidth of the which you need to distinguish between the different pixels on your sensor. Um, and of course, finally, you have to do all the integrations that the perfect image comes to your software at the end. That means this complete synchronization between camera, light, and so on is mandatory before you start uh, uh, with the operation on the images. Here we have simply some ideas where you use these different techniques. For example, also why use backlight, when use backlight, maybe to do the fill level inspection, or here we have the can pressure inspection. Um, these are all high-speed applications where you need the fitting set up to get the optimal data into the image memory and then do the evaluation on this image memory. And of course, in many cases, you have the combination. You have here the measurement of the cap or of the cork or of the pressure. But on the other side, of course, you have a lot of tasks which you have to do, which are not belong to the measurement. Maybe if the label is good or bad or it looks not good, then what I said, AI comes in place, and therefore, anyway, you need uh, also a good image. A good image also uh, allows you to speed up the AI, because if the images are good and not so too much noise inside, even the AI can work faster on the images. Yes, so this was a short intro to, or the idea what is really important um, to do machine vision. Of course, software is a key factor, and I think I mentioned it. The software shouldn't uh, stop you or shouldn't um, uh, be the problem when you select the right sensor. Um, because the first thing is you have a task and you have to think, can I see it in the visible light? Can I see it maybe in the thermal, in the temperature area? Or or do I have to look in the sphere, in the very short wave area? Um, and then uh, based on this, you have to select the right camera sensor. And of course, then it shouldn't be the point where you say, okay, I cannot use this camera, or I have to first invest a lot to implement it. So um, the the software should allow you always to select the right sensor for the right stuff. And finally, then you have to take care that if you have the right sensor, that you have also the right lens and light. I just mentioned the sphere camera. Sphere cameras are really expensive. Well, maybe you know it. It's roughly about 12,000 euros or so. Sometimes some are more expensive. And of course, you cannot use a standard lens in front of a sphere camera, because a standard lens made of normal glass doesn't transfer these uh, short wavelengths to the sensor. That means at the end, you get an image of the only of the part which is in the spectrum where the eye can see it, but what you at the end want to see with the sphere camera um, is cut by the transfer wavelength transfer of the sensor. Many people forget this when they buy sphere cameras, and they wonder, I cannot see. For example, if you have you want to distinguish between coffee beans and whatever, and I wonder, I only see brown stuff or dark stuff, not brown because it's a more gray image. I see only dark stuff, and then I realize, okay, I bought a normal lens, or worse, of course, you need also a light source uh, which emits these wavelengths, because um, the normal light, of course, the sun has also sphere wavelengths inside, but you are normal in the production belt without the sun. So if you use all the standard light, it's not working. So simply consider, if you select all these special sensors, beside that you can use it with your software, that you need a special light and a special lens also, as it's necessary to have the right um, transfer function. If you have a very high resolution sensor, um, and if you have the high resolution sensor, you need a lens which fits to the high resolution sensor. Yes, finally, I think that's what I wanted to go over today with our webinar. And if you have now some questions or so, I'm still here. You can ask them, or you can, of course, um, send me some mails with your questions. If you have a special task where you say, okay, which camera would do it, or which light source, or so on, simply write a mail to me, and I will give you a detailed answer which different manufacturers would fit for the needs of the tasks you have. Yes, so feel free to ask me, or simply send me a mail. If nobody asks, then I would say thank you that you took the time today. Hopefully it was somewhat interesting for you, and to see you at one of our next webinars here on this channel. Thank you very much. Okay, bye-bye.